Here we have a problem on compound interest. Okay, let's go with the information. Nancy and Stacy both open bank accounts at the same time. However, Nancy's account earns 8% interest compounded annually, whereas Stacy's account earns only 4% compounded annually. If Nancy deposited $1,000 initially, approximately how much did Stacy deposit initially in dollars if they have the same amount of money in their accounts after 10 years? Okay, since it's a problem based on compound interest, we can use a formula to find value of a deposit after T years. So first, let me write the formula, that is A equals to P times 1 positive R divided by N raised to the power of N times T. Okay, so this is a formula we use in compound interest. Now let's understand the components of this formula. So this A represents the value of the deposit after T years. That means this T represents a time in years. So this A represents the value of the deposit after T years. And this P represents the initial deposit, and R represents the rate of interest, and this N represents the number of times the interest is being compounded in a year, that is in 1 year. Okay, now let's go over the information here. That is, Nancy deposited $1,000 initially. Since we know the initial deposit of Nancy, so we can plug in this $1,000 for P over here. And also we know the rate of interest for the bank account that Nancy has, it is 8%. And also we know the time is 10 years. So we can plug in this $1,000 over here for P, and we can convert this 8% to decimal, and we can plug in that value for R over here. And N represents the number of times interest is being compounded. So in both the accounts opened by Nancy and Stacy, interest is compounded annually. Compounded annually means once in a year the interest is compounded. Since interest is compounded once in a year, so the value of this N is just 1, because N represents the number of times interest is compounded in a year. Since interest is compounded annually, the value of N is just 1. Okay, now let's calculate the value of the deposit of Nancy after 10 years. Let me do it. Let me write the stuff over here. This is Nancy. Okay, so A equals to P is 1,000 times 1 positive. If I convert this 8%, because Nancy's account earns 8% interest, if I convert this 8% to decimal, I'm getting 0.08 divided by the value of N is 1. So again here I have to plug in N is equal to 1 times the value of T is 10. So then I'm getting A equals to 1000 times 1 positive. Actually 0.08 divided by 1 is 0.08. When I add this 0.08 to 1, I'm getting 1.08 raised to the power of 1 times 10 is just 10. The value we have over here represents the value of Nancy's deposit after 10 years. We can keep this value as it is. We can do simplification later. Okay, now let's go to Stacy's part. That is, let me write the stuff over here, Stacy. Okay, so for Stacy also we have to use the same formula, that is A equals to, actually I do not know the value of P. That is, P represents the amount of money deposited by Stacy initially. That's what we have to find according to the information we have over here. That is how much did Stacy deposit initially. So we have to find the value of P over here. P can be written as it is 1 positive. So what's the value for R? Is the rate of interest. In Stacy's account, we have 4% rate of interest. When I convert this 4% to decimal, it will be 0.04 divided by. So this one also is compounded annually. So the value of N over here is just 1 to the power of 1 times, and the time period is the same. That is 10 years. Let me continue. A equals to P times, when I divide this 0.04 by 1, I'm getting 0.04. When I add that 0.04 to this 1, I'm getting 1.04 raised to the power of 1 times 10 is just 10. Okay, now let's consider an important information over here. That is, they have the same amount of money in their accounts after 10 years. So this whatever value we have in Nancy's account after 10 years, the same amount of money we have in Stacy's account after 10 years. So that is, this is already we know that this is a value of Nancy's deposit after 10 years, and this is the value of Stacy's account after 10 years. So these two stuff must be equal according to the given information. So we can equate them and solve for P. Let me do it over here. That is 1000 times 1.08 raised to the power of 10 equals to P times 1.04 raised to the power of 10. Okay, now my aim is to solve for P. This P represents the amount deposited by Stacy initially. So that's what we have to find. Okay, now let me divide both sides by 1.04 raised to the power of 10 to solve for P over here. Let me divide on the left side by the same value, that is 1.04 to the 10th power. So this one will cancel out. And now we can evaluate this one using calculator. But before that, I think we can do one more work. That is 1000. So this one and this one, both of them are having the same exponent 10. So what we can do is we can write this exponent 10 in common. Then we get 1.08 divided by 1.04 raised to the power of 10 equals to, we have p on the right side. Okay, now let me do some calculations over here. Here we can use a calculator to get the value of this fraction. That is, we have to divide 1.08 by 1.04, and whatever value we are getting for this one has to be raised to the power of 10, and the result has to be multiplied by this 1000. So when I do all these things using calculator, approximately I am getting $1,458 as value of P. Okay, I'm getting a very long decimal. I just round it to the nearest whole number. Then I'm getting 1,458 as value for this numerical expression. So now I got the value of P. Actually, this P represents the money Stacy deposited initially. So like when I go over the answer choices over here, the one which is very close to the value we got over here, 1,458, is 1,460 that we find in answer choice D. So the correct answer choice for this question is D, 1,460.